Hey guys, welcome to the Exam 3 review. In this video, I'm going to cover problems 1 through 3. Try and keep the video short, that way you don't have to watch a bunch of stuff if you don't feel like you need to. So I'll just cover the first page on this first video here. Hope you all are finding good ways to study and get ready for this test. Remember, it's due on Sunday night. So make sure that you go through the entire study guide, review your previous homework, and review your previous quizzes as well to make sure that you're fully ready for that test. All right, so we'll start off here with number 1. This is simply a question that covers your understanding of the different formats of confidence intervals that we had discussed when we talked about those. All right, so there's essentially 3 different formats. There's your plus minus format, where you take your point estimate and you add and subtract the margin of error. And then there is the trilinear inequality. They call it a trilinear because there's 3 parts. And you essentially take your point estimate and tuck it in between the 2 bounds of your interval. Right? And then there's the open interval format, which is, it looks a lot like an ordered pair, kind of like it does down here. So you have your left bound, your right bound separated by a comma and put into parentheses. These are the 3 most common forms for a confidence interval that you'll see in any study. All right. So they gave us a confidence interval here, and all we know are the left and the right bounds of that confidence interval, and they want us to take this from the trilinear inequality to the plus or minus format. And to do that, I have to find this thing, which is the point estimate. Okay. And a point estimate is always going to be the midpoint in between these 2 bounds. So essentially, I got to find what the midpoint is between 0.111 and 0.222. The easy way to do that is just to add the 2 bounds together. So if I take 0.111 and I add to it 0.222, I'll get a result. And then to find the midpoint, all I have to do is divide by 2. It's like taking the average of these 2 values. All right, so I'll pull up my calculator and do that real quick. Go. So we got 0.111 plus 0.222. We got 0.333, right? And then we got to divide that by 2. So we got 0.1665. So I got the first piece of this. So I got 0.1665 plus or minus my margin of error, right? So let me put this 0.1665 here. 0.1665 is the midpoint. The margin of error is going to be the distance from that point estimate to one of the bounds. Right, so all I have to do is go back to my calculator and I can do 0.1665 and subtract this 0.111, and that'll give me a distance from the point estimate to one of the bounds. So we got a distance of 0.0555, so that's going to be my margin of error. So there's my confidence interval in its plus or minus format. All right, and then here number 2, it's kind of the same thing. It's just transferring back and forth between the different formats of those confidence intervals. We start off in an open interval format. They want us to go to the trilinear inequality format, which is actually really easy. We don't need the point estimate for either one of these formats. All we need are the bounds, which we are given right away. So we're doing a confidence interval for the mean. So I'm going to take my mean. I'm going to tuck it in between 2 inequality symbols, just like this. And then I'm going to take my bounds, so this 0.8181, put it on the left side, and then my upper bound 0.9393. And there's my trilinear inequality. So this one was really easy because I didn't have to calculate that point estimate. All right. So let's do problem number 3. All right, so it says a Consumer Reports Research Center survey of 536 women showed that 54% of them purchased clothes online. You want to estimate the population proportion of women who purchase clothes online. So notice what we're doing here. We are estimating something. So this is a setup. Whenever you see that word estimate, that means you're going to be doing a confidence interval. All right, and we're estimating a proportion. All right, so remember we did 3 different types of confidence intervals. We did we did the 1 prop z int, and then we did the t interval and the z interval. And so when we do a proportion, we're going to be doing a 1 prop z int. All right. So the first thing we got to do to use a 1 prop z int confidence interval, we need to make sure that we can establish normality. All right. And with the proportion, we need to make sure that we have at least 10 successes and 10 failures. All right. So if I take the number of successes, and I try to calculate how many successes we had in our sample, all I have to do is take 54% of 536, okay? And so I do 0.54 times 536, and you would find that you had 289 of these 536 women purchase clothes online, right? And then to get the number of failures, you would just do 536 minus the 289 to see who didn't shop for clothes online, and that was 247 of those women. All right, so both were greater than 10. And that means that the sampling distribution is going to be normalized at that point. It's big enough to be normalized. Okay, so this is just a normality check. All right. Then it wants to know what is the best point estimate. So remember, our point estimate comes from our sample data. So we sampled 536 women, and we know that 289 of them shopped online. So our point estimate, which has a notation of p hat, okay, so you put a little p with a hat on it, is going to be 289 out of 536. This is our actual point estimate, and you might want to go ahead and get a decimal for that, which should be 0.54. Let me double check that real quick. 289 divided by the 536. Make sure I didn't mess up a decimal there. Yeah, pretty close, 0.54 there. So, and that's what we had, that's what our survey had said in the beginning anyways. So that 0.54 becomes our point estimate, right? And if we're thinking about our confidence interval, that 0.54, that's going to be what's tucked in between the two inequality symbols. It's also going to be one end of the plus or minus format. So we've got a big piece of our confidence interval just by doing that simple sample proportion from the data, right? So now it says find the critical values that correspond to a 95% confidence level. All right, so this is where we are going to use our normal distribution. So remember our sampling distribution is normal. We established that in part A. And for any normal distribution, if you want to capture 95% of your data in the middle, it's going to kind of look like this, right? And we have these tails, and we know that 95% is going to be trapped in the middle. What we're looking for are these values here that kind of separate that 95% in the middle from the two tails. So to figure out what these critical values are, we just need to do an inverse norm. Okay, so an inverse norm. And if there's 95% in the middle, that means there's 5% split up between these two tails. So we're looking at 0.025 or 2.5% in each of the tails. So I'm going to do a 0.025, comma, 0, comma, 1. And we're doing a standardized normal distribution so we can figure out how many standard deviations away we need to go to get that 95% in the middle. All right, so when I do this one, we get a 1.96 or 19599, depending on how many decimal places you want to go to. I'm going to carry 4 for now, but this would be 1.9599 here, and this would be negative 1.9599 here. So this is telling me I need to go about 1.96 standard deviations to the right and to the left to capture 95% of my distribution here, right? Which is our goal because we want a 95% confidence level. Okay. So let me scroll down here because the next thing we need to do is find the margin of error. All right. So margin of error. The formula has been the same for pretty much all of the confidence interval problems. You're going to take your critical value, right, which we gave a notation of z alpha over 2, and then we multiply it by the standard error. And we know this piece, we found this piece in part C, right? So we know that we need to go 1.95 standard deviations away. Now we just need to figure out what a standard deviation is so that we know how far to go away in our distribution. Okay? So the calculation for standard error does change depending on what kind of confidence interval you're doing. This is for a proportion, right? So we're going to be looking, this is the one with the big square root calculation, right? Where we have p times 1 minus p all over n, and this is all inside of a square root. Okay, so I'm going to go here and I'm going to say, okay, well, my proportion from my sample was 0.54, and then we would do 1 minus 0.54, and then we would divide by our sample size, which was 536, and that's all got to go inside of a square root. So you would go to your calculator, you would crunch those numbers, be careful, make sure you do it in order, and don't mess up your order of operations there. And what you should get is 0.02153. So the distribution that describes our situation, one standard deviation is 0.2153, and we need to go 1.95 of those away in either direction to create our confidence interval. Okay, so our margin of error is 1.9599 times 0.0215. Right? And if I multiply those two things in my calculator, I get 0.04222. One too many twos. There we go. So this is my margin of error. And that's actually the last piece that we needed, right? Because this is supposed to be 0.54 plus or minus my margin of error. So I'm going to go ahead and construct my interval now. Point estimate, 0.54 plus or minus 0.0422. So that's one way to express that. The other way would be to actually add and subtract that 0.0422 from the 0.54. And if you do that, you can set up an open interval like this. You can do 0.49698. And then the upper bound would be 0.58138. All right, and if you wanted to set up a trilinear inequality, you make sure you use the correct symbol here. You're going to say proportion, tuck it in between two inequality symbols, and then you just put your upper and lower bound. So 0.49698 over here and 0.58138. All right, so that is the construction of our confidence interval, and you could do that on your calculator as well. I showed you how to do it by hand there, but you could do it on your calculator fairly simply. We go over here to tests, and what we did was a 1 prop z int. So you're going to go down until you see 1 prop z int. That would be the correct test on the calculator for proportion. And we're going to do our number of successes, which we pointed out was 289. And then the sample size was 536. And our confidence level was 95%, and then we'll calculate. We should get the same numbers that we have on our page there, and sure enough, we do. Right, these are the same exact things that we calculated by hand. All right, so that's how you do that. And if you want, I would probably make a note on here, like if you wanted to do that on your calculator, this is the correct test on the calculator for this situation. All right, last thing we need to do is just interpret our confidence interval. What is it that we just found? What we found is an interval that we think contains the true proportion of women that buy clothes online. So we would say something to the effect of, we are 95% confident that the true proportion or actual proportion, however you want to word that, of women who shop online or who buy clothes online is between these two numbers, right? So between 0.49698 and 0.58138. All right, so this would be a really good interpretation of that confidence interval. Do not, under any circumstances, say that there's a 95% chance or a 95% probability or that 95% of the time. All of those are indicating to me that you think there's a probability associated with this confidence interval, and it's not. It's not a 95% probability that the proportion is in between these two values, okay? I would have to automatically mark that wrong. It's just, it's a confidence level, which indicates that if I ran this experiment 100 times, 95 out of 100 times, we would capture the true population proportion, all right? But there is either a 0 or a 100% chance that the actual proportion is in this interval that we found, not a 95% chance, all right? It's just we're 95% confident. It's totally different meaning, all right? All right, guys, that is problems 1 through 3. Hopefully that was helpful for you. If you have any questions or that did not answer all of your questions, make sure you send me an email and maybe we can set up something where I can explain it in further detail for you. All right, have a great day.